Hello students, and welcome to the CompTIA Network+009 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 1 in the exam objectives. We're going to discuss Section 1.4. In our first, which will be this one, we're going to discuss Internet Protocol Types. Let's begin. We're going to begin our discussion in this episode with ICMP, the Internet Control Message Protocol. ICMP is a protocol that we can use to track the data transfer of our IP packets across the network. ICMP has several very helpful features to help us to identify when we've had some type of failure in the transmission of a data packet. One feature of ICMP is error reporting. We can use the ICMP protocol to send us error messages when there has been some type of operational failure in the processing and sending of an IP data packet. With ICMP, we can also use some command line diagnostic tools that will help us to identify if there has been a failure in the data path from source to destination. We can use commands like ping and traceroute to help us to identify the data path and whether or not there has been a break in the network path. We also can use ICMP to identify the current health of all of our network connections. We can gain data about the data transfer speed as well as our bandwidth utilization to help us identify where we may have areas of bottlenecking or congestion. Next, we're going to discuss the TCP protocol, Transmission Control Protocol. TCP is a connection-oriented protocol. That means that whenever we are sending or transmitting data across the network, we will have a definitive beginning and end to the session where we are sending and receiving our data. TCP is a protocol that's very popular because it provides data integrity. TCP allows for error checking. If we have any errors in the sequencing of the data packets going across the network, TCP can take those out of order data packets and reassemble them at destination. TCP also allows for retransmission of data packets. If there has been any data that has been lost during transmission, TCP can resend the data packet that failed to reach its final destination. With TCP, we also can practice flow control. This is where we can manage the size of all of the files and data packets that are going across the network. This helps us to make sure that we have a nice, efficient traffic flow for all of the data packets as they're going across the network. Let's contrast that with UDP, the User Datagram Protocol. UDP is a connectionless protocol. It's one that will keep a connection open at any time to allow for the transmission of data, but we do so without the error checking features of TCP. If we're using UDP, we will not have any error checking or packet recovery as we do in TCP. We will rely on the application that is running for data integrity of all of our packets. Because we are doing without all of the error checking and recovery features of TCP, it allows us to have a faster data transmission rate. But because we are lacking those features, we're going to have a less reliable communication. Many times we use UDP for features like our DHCP for IP address assignment, as well as real-time applications such as streaming and online gaming. Next, we're going to discuss GRE routing. GRE stands for Generic Routing Encapsulation. GRE routing is a technology we can use to allow several different types of data traffic to go across the same point-to-point connection. Many times we use GRE with our VPN tunnels. A VPN tunnel is when a remote user will establish a secure encrypted connection over the public internet to our internal network resources. And we can use GRE routing to allow the remote user to send multiple types of data traffic through that tunnel. GRE is very popular because it is flexible and interoperable. We can use many different types of data traffics, as well as using the routing capability within all of your operating systems, Windows, Mac OS, and Linux. Next, we're going to discuss IPsec, Internet Protocol Security. IPsec is a suite of tools that we use to provide data security and encryption for all of the data going across our IP networks. With IPsec, we have data encryption. That means all of the data that are contained within our IP packets will be encrypted. This helps to protect from attackers that may be eavesdropping on our network connections. IPsec will also implement our authentication mechanisms. This will be how our users can authenticate themselves to the network to make sure that all of the data packets that are being sent and received are coming from authenticated users. Many times we use IPsec with our VPN tunnels. It allows us to incorporate all of our data traffic in an already secured and encrypted tunnel. IPsec has a couple different parts within its encryption framework. First, we want to discuss authentication headers, or AH. Your authentication header is the one part of the data packet that will not be encrypted. It's going to be a header on the front of the payload of the IP packet that will provide a small collection of data bits that will contain some type of identifier for that packet. And on the destination, when the packet has been received, we can check to make sure that the authentication header has not been changed in any way. If it has, that is a clear sign the data packet may have been tampered with. Another element of IPsec is the ESP payload, the encapsulation security payload. Your ESP payload is going to be all of the data contained within the IP packet that is going to be what is viewed at the destination by the end user. In our ESP payload, we're going to encrypt the entire data packet. And for the destination user to be able to view all of the data, they will have to have the appropriate decryption key. Within your ESP payload, you will have a header and a trailer. The header and the trailer will act as identifiers within the data payload for security information. This acts similar to the authentication header, where any change or modification in the header or trailer is a clear sign that we may have had tampering with the packet and our data may have been compromised. We also want to understand Internet Key Exchange. Internet Key Exchange is how we manage all of the cryptographic keys within IPsec. With Internet Key Exchange, we can create new encryption and decryption keys for data going across our IP network. It also allows us to incorporate any additional encryption or wireless security if we are using a wireless network. Our Internet Key Exchange will be able to integrate with any wireless access points that may be set up for encryption as well. With Internet Key Exchange, we can take all of the newly created cryptographic keys and we can automatically set those up with the different sessions and tunnels that are created within IPsec. And in the last part of this episode, we're going to discuss several different traffic types. These are going to be ways that we can send data packets across the network to different recipients. First, we have unicast. A unicast is when a data payload is sent from one sender to a single recipient. Unicasting is used for standard tasks like web browsing and file transfer. It's going to be a direct communication between two distinct individual devices. Next is a multicast. A multicast is typically used for group communications. It's when one sender will send data to multiple recipients in a group. Within multicasting, we need to identify the specific individuals that will receive the data transmission. Multicasting is very efficient for our bandwidth use. By having a single stream to multiple recipients, it limits the amount of data transmissions that has to go through our network equipment. We use multicasting for our streaming media, online gaming, and other group or collaborative applications. Next, we have broadcasting. A broadcast is going to be a network-wide communication. It's where one sender can send a payload to all of the connected devices within a network segment. Broadcasting is commonly used in our IP version 4 networks, and we use it for network discovery protocols like DHCP, where we can discover network devices and assign IP addresses, as well as ARP, the Address Resolution Protocol, that helps to make sure that we don't have any addressing conflicts on the network. And lastly is Anycast. Anycast is when an individual will send a data request for the nearest type of a specific type of resource. Many times we use Anycasts to identify a nearby server. For example, if we want to identify the nearest DNS server, web server, or DHCP server, we can send an Anycast message out onto the network. And our message will be forwarded along the network to the most proximate location where the requested server is located. That will conclude our discussion of the first half of Section 1.4, Internet Protocol Types. In our next episode, we will move on and conclude the section by discussing network ports and protocols. We thank you again for following along in the episodes in the course and wish you best of luck in your studies. Enjoy the rest of your day.